Are you able to do complex calculations with software? Do you know how to write code and build applications? Do you already have the skills that you will need in your job in 10 years? That is actually a trick question because it is impossible to know what will happen in 10 years. The world is changing faster and faster, and there's no way of knowing what the next ChatGPT will be. Right now, everyone's talking about AI, but just a few months ago, people were talking about other technologies. There's no way of knowing what the next big invention will be. Do you have what it takes to be a successful employee in the new job market that is emerging? For centuries, technology has changed the world, changed the way that we work, the way that we live, the way that we cook. Everything from the invention of fire to the invention of the wheel, to even the invention of computers and the beginning of the information age. Over time, the pace of innovation has continually been picking up, and more changes are happening every single year. This is especially true since the invention of the computer. First, transistors were not even a thing. Computers used pipes and gas, but now computers use transistors. They used to be this big, but now transistors today are so small that they are reaching the level of quantum physics. The change in computing happened exponentially, not linearly. It sped up over time at an insane rate. Skills such as coding, entering data into Excel for complex calculations, or setting up very expensive equipment are becoming more ubiquitous than ever before. Both you and I will have to react to market changes very quickly. There is no telling what the job market of the future will require. That raises the question, how can you learn faster so that you can stay ahead of automation? How can you learn fast enough to catch up with the rapid pace of innovation in technology? I fortunately know a secret to learning things much faster, and I learned it from one book. This book was a game changer for me. In the first semester of my computer science degree, I really struggled. Many other students flew past me, studying twice as effectively as I did. I wondered if it was due to my intelligence. Was it my health? Outside circumstances? The most pressing question I had was, is there anything that I can do to improve my situation and learn faster? This book tells the story of a blogger named Scott Young and how he started his ultralearning journey. It was in those first crucial months of my degree that I came across Scott's story. After finishing a Bachelor of Arts in Business Administration, Scott wasn't sure what to do with his life. He had dreamt of building a business and getting to know how to be creative in the market. But unfortunately, Scott had not learned any of that. All that Scott had learned from his business degree was how to do standard operating procedures. He felt more like a robot than a creative person. Scott found out that what he really wanted to know was computer science. But computer science was not the degree he had done. What should he do now? Should he go back and study computer science, get a second bachelor's degree? Or was there an alternative? It was at this time that Scott found out that MIT posted all of their courses online. So what Scott did is he went through MIT OpenCourseWare and got every single class of the bachelor's degree curriculum. After assembling the full curriculum for a bachelor's degree, Scott finished the degree in only 12 months. How did he do it? Is it even possible to do a degree at such a high pace? Finishing the entire bachelor curriculum for computer science from MIT in only 12 months was not the only impressive project that Scott did. But he knew from his interactions on forums on the internet that he was not the only one. He even met up with other people and made friends who would also study and learn at an insane pace. The book documents observations that Scott made about what makes someone a very productive learner. Was this perhaps the missing ingredient for my own studies? While in university, I studied alongside some of the most efficient and productive students in my entire country. I went to a northern German university that selected students based on a test, and based on whether a company was willing to cooperate with them. Our program was built as follows. We would do 40 hours of work every week for most of the year. But once every semester, we would take a break from working for 10 weeks. The first 9 weeks were jam-packed with classes and studying and preparation. Any projects, homework assignments, or other graded activities were done in these 9 weeks. On the 10th week, all the exams for the entire semester were taken. As soon as the exam week was over, we'd go straight back to work. Because of the high pace of working and studying, many people fell behind. The so-called co-op degree program, or as it's called in German, duales Studium, which also exists in Canada and some other countries, was extremely fast-paced. This system of studying for 10 weeks and going back to work went on for 7 semesters. The contracts that students had made with their employers demanded that they finish their degree on time, or with the maximum of 6 months of extension. The contract demanded that students do what only 20% of students in Germany are able to do. This insane pace was very stressful. So how is it that over half of my class graduated with me on time? Besides there of course being certain unfair advantages that some students might have had, there was one thing that everyone who finished the degree on time had in common. Either by intuition or because of previous experience that they gathered in high school, the most successful students were those who implemented the same principles that Scott suggests in his book. But what are these principles? The first principle is metalearning. Discover how past experiences and things you have previously learned can help you learn new things. The second principle is focus. Sharpen the knife that is your mind. If a chef doesn't sharpen his knife, he is not a productive cook. The same is true for anyone who is trying to learn a new skill. Your mind needs to be able to focus on the task that you are doing at will. A great way to focus is to get into a flow state, a state where the task that you are doing is not too difficult and not too hard. Focus is like a muscle. You can train this muscle to be able to learn anything faster. The more focused that you are while you are learning something, the faster you will learn. The third point is directness. It's important that you practice exactly what you are trying to be able to do. For example, if you are learning how to shoot with a bow and arrow, watching videos on YouTube about shooting with bows and arrows and reading about it will not help you. If you are learning to play the piano, reading about music theory is useful, but it is not sufficient. If you want to play an instrument, you have to sit down and actually practice. The same applies to any other skill. Practice specifically what you are trying to get better at. This is why it's so important that you know exactly what you want to learn before you get started. The fourth principle is drill. When you're practicing, you will notice that there will be certain parts of the skill that you're trying to learn that are the hardest for you. The weakest link in the chain is the most important one to reinforce, because a chain breaks apart at its weakest link. Maybe use flashcards to memorize specific words that you need to know. If you're learning a new programming language, practice exactly the parts that you struggle with the most. Any complex skill can be broken down into smaller sub-skills. You need to master every one of those sub-skills if you want to be good at the skill that you're trying to learn. Principle number 5 is retrieval. Test to learn. The best way for you to learn something is not by reading it passively or watching videos about it. The best way to learn something new is by trying to do it yourself. If you're trying to code something, don't just follow a tutorial. That's how you get stuck in tutorial hell. The best way to learn to code is to learn some basic concepts and start practicing. Start writing code. Pick a project that motivates you, that inspires you. Maybe you're motivated to code because you want to make a game, or a mobile app, or a website, or you want to build an AI model. That's great. Use the motivation you have for an end goal and build a project in that direction. Only use guides and tutorials to help you build a foundation, but build on that foundation by writing code yourself. Principle number 6 is feedback. Don't dodge the punches. If you see that you are not doing well in a certain area, you need to listen to that data. If you have the luxury of an instructor, listen to them. If they tell you that you need to work harder on specific parts of your coding, then do that. If there are certain algorithms that you struggle to master, you need to focus on those. It's very uncomfortable to focus on your weaknesses, but if those weaknesses are keeping you from becoming better at the skill that you're learning, you need to deal with them. Principle number 7 is retention. Don't fill a leaky bucket. It's no good learning something if you're going to forget it immediately after that. That's where spaced repetition comes in. Use flashcard software like Anki, or plan your sessions with logarithmic spacing. First practice every day, then every 2 days, then every 4 days, and continue increasing the space between your repetitions. By spacing out your repetitions of what you've already learned, you can make sure that you never forget what you just learned. Principle number 8 is intuition. You need to have an intuitive understanding of things if you really want to know them well. It's not enough to just memorize some facts and not reflect them. Memorization can help you, yes, but it's no replacement for intuition. Dig as deep as you can into a subfield that you're learning so that you can build up. Any strong house needs a strong foundation. Don't neglect theoretical fundamentals of computer science. For software engineering, data science, and related fields, the foundation that you need is algorithms and data structures, as well as certain parts of discrete math. If you're doing a degree, your degree will teach you those. Don't just know the facts, understand them, incorporate them into your coding. Knowing theoretical computer science will help you a lot. Make sure that when you're coding, you are actually thinking about algorithms you have learned previously. Think about big O notation. Write code with consideration to the time complexity that that code has. The most important part of software engineering is figuring out what to write, not only how to write it. Principle 9 is experimentation. It's important that you try new things out. Explore out of your comfort zone. Don't just stick to one programming language forever, for instance. Once you have mastered one language, learn another one. If you started with Python, try learning some C, or C# or Java. Expand your knowledge. Strive to become someone who is versatile and can work with multiple tools. Look into DevOps. Look into data analytics. Explore new things and always learn. Try out new ways of learning to code. Discover what works for you. If you want to learn technical skills faster, you need to take learning into your own hands. No one is going to do it for you. The job market will require unimaginable skills in the future. There's no way of knowing what will be the most important thing to learn. What you can do is use the fundamentals that you have to stay ahead of automation. Even if some part of DevOps gets automated, there will be parts that are not automated. If some part of writing code is taken by AI, there is still engineering and architecture and design. If you learn efficiently, you can stay ahead of automation. By applying the principles of ultralearning, you too can have an amazing career. The responsibility for keeping up is yours. It's your life. Make the most out of it. You've got this. Happy learning!